Okay, so today I am going to talk about the Go routine, some more concept. So let's consider the one case. Let's see, I can start the multiple Go routine. Go routine once, okay, they are doing some work. Go routine, another Go routine, they are doing some work. Maybe another Go routine, they are doing some work. Okay, so Go routines are the small lightweight threads. They are executed independently. And let's see our mains, the Go routines started this Go routine 1, Go routine 2, Go routine 3. And our objective, sometime I want to ensure that these all Go routines are completed, and after that I can maybe start some my work or the next Go routine. So somehow I want maybe main Go routines. Started this Go routine. Now main want ensure that this Go routines, this Go routine are completed. After that, I want to do some additional works. Okay, so how we are going to ensure? So by default, whenever you start multiple Go routines, okay, they are executed separately and different contexts, and until even not telling main Go routine, hey, we have to wait somehow for these Go routines. By default nature, our complete main Go routines which are started this Go routines are thread, they are going to by default close your program, even you cannot get any kind of output. So let's example. So here let's see, I can just write one Go routine go and just say so here say, let's say your Go routine once. Okay, and you can say caught, or even just instead of this, say just write another function here, function task. Okay, and this will take what take just simple, not answer, and here simply say for loop and takes this count, maybe one count. Okay, and just empty dot print your count. Okay, or just say what are the message, let's say string message, a message string message, and here let's our Go routine plays 5 times, and just your message comma 1. Okay, this is simple function. They take some, and if you call from the normal as a function, okay, call this way. So if you are simply, let's say simply call our task and pass task 1. Okay, if you run this code, it's work very fine, because simple one functions you are calling, they are printing 5 times your message 1 2 3 4 5, because simple there, it's okay, there's no problem. Okay, so now let's I can say, hey, go with the Go routines, just say Go routine, and then observe what the output, because this is after that say, hey, something let's main function is completed, main function is done. So if this if you without Go routines, this is simple one task, and task is started, they are doing something, and after that say main, say, hey, main is done. So main is also by default you can say one Go routine function. Okay, so this is the one Go routines where this task is done and this task is done. It's okay, there is no problem. Your main one go routines is started. They are what saying, they are going to the call one function, and one function printed all the message, then again back and they print our message and say program is closed. So by default go only one main go routine is started. Okay, and now what happened, let's say I say, hey, I say now main function, here say main functions are main go routine is started, okay, and this is the done. Okay, and if I say let's start another go routine, so here now our main one main go routine, is started, main go routine is function. And now if you run here and then observe the output, so what happened, main go routine started another go routine, and after that what the output. So you could notice main go routine started, main go routine done, with the output by this go routines. Okay, so this is kind of a sometime whenever your one go routine, in this case our main go routines, are going to start another go routines, they are started but they are doing some another work, but after they started, this is the asynchronous concurrent programmings, our mains go routines are going to the continue his works, and after the continue his works this run, and now this function main go routine is completed, and this whole main go routine going to the complete. So in anyhow our main go routines started another go routine, but they main is not waiting until these are not completed. So how, what the mechanism, we have to wait at least so that this started go routine are not closed. Maybe we can start multiple go routine 1, go routine 2, multiple go routine is started. Let's might be here. I can start it task go routine task 1, task 2, go routine task 3. Okay. So what happened if you run the code? Our expectation mainly started. They started 3 child go routines. This is the main, and they started one go routine. They started another go routine. They started another go routine, right? And after main, whatever the main activities, printing something. So by default, we can get this line. We can get this line. These are the started where, but they are doing some works, right? The message recording. But these main go routines are not waiting. So all the output is can be sometime you can view some output until your main is not closed. Whenever your main go routine is going to the close, all the sub go routines or child go routine by default going to the close. So we are not getting any kind of outputs. Okay, if you run, notice main started and the program is terminated. So in this scenario, I want to know these go routines just wait. Okay, so for that, a very basic you can say primitives provided by the Go library. Just use the wait group. This is the one wait group, and wait group have a kind of a 3 methods. One is your add method, another is your done method, another is your wait method. That means whenever your main say, hey, started one go routine. Okay, so somehow you can say, hey main, this is the my one waiting group. You can started one, I can set 1, and after that I can say, hey, here I am going to the wait, because one go routine started and I am going to the wait. This wait is going to wait until your main count become a 0. So whenever you can say start one, I can add one, and whenever you can say one, this one thread is started until this thread is not completed. We are not saying done. So here somehow this go routines, once his work done, then say, hey, I done. When until they are not saying done, these go routines are going to the wait. So what are the steps? Again, understand. So this is the main go routines, and they created one wait group. Hey, this is a waiting group, and I can say, hey, I'm going to start one go routines. One go routine is started. They are doing something. Okay, and after whenever the go routine is started, they return back again here, and after they are going to the, by default they are going to the complete our main go routine. But I'm saying, hey, don't get, just wait until this go routine is not done. But how this method know, okay, hey, this is done or not done? So somehow they are going to say, hey, done method. They are going to call done method. When they are going to call done method, then this would say, hey, this whatever the go routine started, they completed, and I am going to further executing. So here we can start wait group, and here say, hey, wait group dot, just say wait. So main group started here, and they are going to the wait. Wait say until this main go routine going to the wait. Simple say, hey, main go routine is going to wait to complete sub go routine. Sub go routines. Okay. So here, so question is that key, how many times this go routine going to the wait? If you started, that's good. But let's as of now, I can say, hey, I can start here. I can starting one go routine. So here before that, say, hey, wait group dot add one. So you can say this. They are going to add for one go routine. Now you started one go routine, but this go routine task somehow they have to say done. After that, they are going to the done. Hey, it is done. So somehow this wait group object, you have to pass here somehow. So you have to pass here wait group object, and here you can pass as a parameter, second parameter, let it wait group. So whenever you can pass wait group, now wait group have a method. Whenever this activity is done, after they say, hey, wait group dot done. That is the way. In that means you are ensuring that whenever this method is completed, at that time I say, hey, wait group done. Whoever going to wait for me, let's complete. So here main going to start one go routines, and going to the wait again starting go routine, again starting. So here as of now, let's say commented out. Okay, just one for. Okay. So we started one go routines and going to the wait until this is not completed. How so? This method say once are all done, I can say my flag is done. So if you run here, and is this time you can notice the output. What is this? I have to import somehow. I have to import this thing. Okay. Okay, so notice main go routine is started here. Main go routine going to started, and after that wait group, we are going to say, hey, let's start another go routine. And after that, you can say just another go routine. After that, here I am going to the wait. Here I am going to the wait. This waiting until our task is not completed. Here 0, 1, 2, 3, 4 completed. It's a done, and after that you can say, hey, you are done. Let's go continue to your main go routines. So this is the way, very simplest way we can our one go routine can wait for another go routines. So this is our main go routines doing some work, and here they can start another go routine They can start in the Goroutines, and after that again return back quickly. They just started one call and again going to do his works. Okay, going to do his works. But I don't want this. After this line, they are don't want to continue the further code, further exit. So I can say, hey, here wait until this is not done. And whenever this Goroutine take a time to run, done, and once it's complete code done, that time say, hey, it is a done. So when it's a done, that wait group get notification, hey, it's done, let's continue. Okay, so before starting Goroutines, we have to create one wait group variables, and we can say, hey, I'm going to start one our Goroutines, so add one. Okay, so this wait group say, hey, you are already added one, and once they are going to the wait group dot wait, they are going to wait until your count not become a 0. So they have already set 1. This is the wait group, just waiting until it's not become a 0. So they are waiting. So whenever this Goroutine internally saying, hey, done, whenever say done, this count become a 0, and this wait get a signal, hey, I am going to the wait is my over. So maybe here you can start the multiple. Maybe say, hey, maybe we get multiple. Maybe start multiple. Then what happened? So let's pass here. So what do you think? It's wait for all three or what? Because here you can say wait for one. Any one say it's done, then it's go over. But let's check output. So notice here Goroutine start only one done, and after that our main program is completed. So somehow you can say, hey, this is another, add another, and maybe add another. You can do this way, add one, similarly become a 3, or you can simply say, I'm going to start 3. So instead of that copying this, instead of doing this, we can simply say, hey, I am going to start 3 tasks. Okay, whatever preferences way. Okay, so let's check here. So here say I am going to start 3 wait group. So this wait function is going to wait until all these are not completed. How this task say completed? Because here whatever the logic done, they say completed. So generally this is the one way. Whenever you complete your code and after that you say done, what happens? Sometimes it's exception occur, and some you are writing some file system, maybe API call, some exception happen, then might be this method can be not called. But you have to ensure that this always be called whenever this function is completed. If this function completed normally, yeah, abnormally. So instead of calling this function here, you simply say another concept in GoLang, say deferred and wait group dot done. What this method say? Defer is the concept. Whenever Go compiler and defer means they are not going to the call this method now. They say कि whenever this function task is going to the complete, whenever you are going to return back from this method, at that time I am going to the call this done method. So defer means just going to defer the execution that method now, but they are ensuring that whenever this method complete, after that I will going to the call this method. The preferable way you can use the defer wait group dot done. That means this done method is not invoked at this line. This will invoke when this function complete. Okay, and so let's check. So notice here task 3 completed, task 2 completed, and task 1 completed, and after that you are going to the main Goroutine. So in this way you can say our wait group help us ensure that one Goroutines can wait for another set of Goroutines. Okay, here our example main R started one Goroutine, they started another Goroutine, they started another Goroutine. Now here main are going to the wait until all these three are not done. So how to do? Just we create one wait group and associate, and each Goroutines have a one references of just look like a wait group is the one object created, and here say I am going to start the three Goroutine 1, Goroutine 2, Goroutine 3. So you can say add 1, that means the one Goroutine, add 1, that means become a 2, add 3, add become a 3. That means this wait group know you have started 3 threads, and whenever after starting they return back quickly. After start they return quickly. After start they return quickly, and after that they are going to their waiting until this count become a 0. Now this count is a 3, not 0. This main Goroutines are waiting. So how this is going to be? Let's this Goroutines is completed and say done. Whenever say done here, it's reduced the 2. This also said done, this become a 1. This said done, this become a 0. Whenever this become a 0, our wait is completed, and now they are going to execute a further code, and main is the completed. So this is scenario where you use the wait group is the very simplest way. Whenever number of threads you are going to starting, do here, and in the inside your code bases you can simply say, hey, it's done. So hope it's clear how you one Goroutines are wait for another Goroutine to complete. So we are using the existing library wait group. Wait group have a generally the number of Goroutines you are going to start. You can just call add one time one, or directly you put the 3 if you know, and after that we have to call the wait method. Wait is waiting until all these Goroutines are not completed. Great. And let's talk one more context. So one more a very good scenario of let's one Goroutine. This is one Goroutine. Let's say I started three Goroutines, and each Goroutines are using some shared object, shared variable. Okay, this is accessed by this is accessed by this is accessed by this, and at this time scenario, sometime this is my very critical resources, a very important component, and this can be accessed by the multiple Goroutines. Okay, so our application sometime required, no, I want at a time only one Goroutine can enter inside the critical section, and other can just wait. So once only one Goroutine can going to execute are working, and once this done, they can say I'm done, then another Goroutine take a chance. So here what I'm trying to say, sometime required in the case of multiple Goroutines, only one Goroutine at a time execute some code, some variable, some shared object. So in this scenario, how as a programmer we are ensuring that this particular piece of code, piece of functions are executed by only one Goroutine at a time. Okay, for that again one more Goroutine concurrency primitive provided by the GoLang library about this Mutex, mutual exclusion. The Mutex is one of the kind of techniques where they are going to ensure that the particular shared resources are used by the only one. Okay, so let's go to the example. So I'm going to comment everything. Okay, so what the here example I'm going to write. So let us here. So let's I write simply one variable count. Okay, okay, count, and here just like some for loop. Okay, for count. Okay, let's 100,000 times, and here say just counter plus plus. Okay, and just say after that print counter. So what we did here, this is the one variable counter. I am going to in the loop and incrementing the 100,000 times, 1 million, right? 1 million. If I run this code, it will give me the exact 1 million data. Okay, this is no problem. Count is the 1 million. That's great. Why? Because this code is just executed by the only one goroutine, that is the main goroutines. So there is no any confusion. This is our counter is a share variable. Counter is a share variable, and that accessed by the only one goroutine at times. They are going to do. This is our count plus plus. Okay, so notice count plus plus is the syntax that generally means count equal to count plus 1. So this is the one critical code sections, and that can be currently executed by the only one thread. What happened? I can start the multiple goroutine, another goroutines. Okay, so in that case, might be you are getting the different outputs. Let's check. So here it's okay. So if we have a start this with another goroutine, let's just start the goroutines. Go function, and I can just return here. Okay, so this is the if only one goroutines, it's okay, it's fine. One goroutines, they are working under this shared variable. What happened? I am going to start the multiple goroutines. Let's say I take a for loop, and I can start maybe 5 times, and the same goroutine I'm going to say, hey, these goroutines are going to start by loop under five goroutines. Okay, so what you are doing? So I'm going to starting 5 goroutines, and each goroutines are accessing this the counter is a share variable, and they're going to do plus plus. Okay, and after that I'm going to get the counter. So if we carefully run here, you notice I am getting something different output. Notice why this is something different? Because if let's say I give only one goroutines. If only one goroutines and I run, I am getting 0. Why? Because this main goroutines are not waiting to completion here. That means again the same. We have already used our this wait group variable. Wait group variable, I can say, hey, wait group, just comment out another create variable here. So let's say I can say, hey, here I am going to say variable wait group. Okay, and here say these wait groups are going to dot add 1. Okay, and once this function done, they differ done. So here we are just what we are going to do is whenever main goroutine start, our this internal one goroutine is also going to done his works. Okay, and after that we are just printing counter. So at least I am getting what is wrong here. What I did something counter save. Yes, I think already this counter is the variables. This counter count plus plus. Let's compile. Okay, you are getting count. Wait. One row routines. They start from 0 to the count plus plus go routine 0. Why are they? I am saying, hey, go routine wait. Okay, I miss here to say wait before printing. Right now we have to wait. So I'm going to say, hey, wait group, this go routine or until not completed is work, just wait, and after that I print the counter. So now we're getting expected out. Great. So this is the one go routine. Let's say I start two go routines. And then what is the output? Somehow I selected. Notice this is the 2000. Great. So let's go for the 3. Means ki all the two go routines are work properly, right? So let's go for the 3. So notice for 3, I'm not getting the exact value. Should be 300,000. I'm getting something different. Maybe let's for the 5. What the objective here? What I'm trying to say. So here, so one go routines. This is the one go routines. This is your share variable count. This one go routine are going to the plus 1 million times. This they say it is a 1 million. Another go routine they can also doing to 1 million plus 2 million. Another go routines 1 million. If I started a 5 go routines, the value should be 5 million. 5 million, but I am not getting the 5. Why? Or even the case of 3, I'm not getting the 3 million data. Because this is the shared variable. Okay, so if let's keep c equal to c plus 1. Okay, so initially let's keep go routine doing something, another go routine doing something, another go routine doing something. So in this case, multiple go routines are allowed to do these works. Due to that, the value of one go routine may be replaced by another go routine. This is the problem, because this is the not synchronous operation, so we cannot allow this line of codes are computed by the multiple threads. If only one threads, there is no problem, because no other threads are trying to raise or change the value of different threads. So in this scenario, sometime I want this code at a time only one thread can execute, not more than 2 threads can execute. So this is the code I want. This should be executed by the only one. Okay, so I'll do. Okay, so for this scenario, I say we have already inbuilt mutex. So you can say, hey, one variable mutex, and just check one mutex, and this mutex have a function kind of a what's a function. So whatever the shared resources and whatever the number of your go routine 1, go routine 2, go routine 3, try to access. So before we have to apply some kind of lock. If any thread get a chance of lock, before they are going to the work, they apply some lock. If any one thread get a lock, then they are doing works, and once done, they release the lock. Then another thread to get a chance. So lock kind of permits. Okay, so if this is the section of code you want at a time only one thread or only one go routine going to execute this code, then first take a lock. If you get a lock, then do, and after that release the lock. The same thing here, say, hey, this is my critical code. I want this should be executed by only one thread. So here say, hey, mutex dot get a lock. Once your code is done, then say mutex dot unlock. Okay, so this is the scenario, the way you are able to ensure that our 5 threads are sharing the same resources, but at a time only one go routines are executed, because you are applying some lock concept. Means you are saying, now it's run, it should give us the 5 million value, because I started the 5 go routine and each go routines are just adding 1 million data. Now we are getting the 5 millions of the data. So in this case, whatever the number of you can increase your Go routines, always ensuring this value are the correct value. So sometime in the multiple Go routine environment, you want at a time only one thread can access my shared resources, yes, shared object. So those scenario, this mutex is also very healthy in nature. Okay, so this is the one way. But notice here you can write any kind of business operation, business logic, multiple call, any kind of codes here. So these are the mutex. But for this example, maybe simplest way, I am using some increment decrement number. So for that, Go library already provided some inbuilt atomic operation. Atomic operation means some atomic object they have created for us. And atomic object means ki whatever the operation are doing on this any atomic at a time by default only one threads or only one go routines allow. Even this concept mutual exclusion lock and unlock already implemented by some like atomic operations. The similar kind of a code. So let's just comment out. I'm trying to say even for the just commenting out here, and I'm going to write another form here. So instead of mutex, by default Go library also provides some kind of a inbuilt. So here it's okay, and I'm not going to use the mutex. Okay, if you are running for 8 Go routines, each Go routines are going to add this millions of number, and we are finally getting the output. So in this scenario, I'm not getting the as expected output because we are not ensuring that at a time only one thread can do increment operation, right? So for that, we are instead of simple variable, why I cannot use the atomic and your maybe integer in 32 or in 64. Okay, so now you can say this is the your counter is the your atomic counter atomic value. Okay. Count integer counter atomic counter atomic int counter. Okay. Just a variable. So here this is the some inbuilt library provided by the our Go standard, and these are the Go standard library, and they say hey, whatever the lock and unlock by default these variables you are thread shape instead of that hey dot you have an option like add, and just I want to add one. Okay, increment we add one. So now you can say hey, and after that you want to just get value, you can suggest hey load the value whatever you want to load. Okay, so your atomic int counter. Okay, so in this way you can also address some kind of numbers. By default atomic have a lots of package, and you can just explore like a signed, unsigned, integer, float. Okay, and you can get the same kind of a behavior, but this is for a specific which our Go library have provided some atomic operations, and you get the same results. Okay, so these are the you can say when you can answer and export here. Okay, so this is the generally preferable way. Any places your code, your set of code, you want to ensure that queue at a time only one thread can use, only one Go routine can access, then you can say lock and unlock. That means Yeah. So scenario, whenever you have a shared some code, some object, and these shared object are accessed by your multiple Go routines, you are going to allow here to access. At that time, your application, your business needs say, hey, at a time only one Go routine allowed to execute some set of code. At that time, you are apply the concept of lock. First, you apply the lock, and if any thread first go take a lock. If lock, then do something, and after that, once done, they are going out and release the lock, so that another thread get a locks and do some operation, and once done, release the lock. Then another thread get a lock and do works and release the lock. So this is the concept of lock and unlock. Means once you done, just release the lock. So this is the way Mutex.lock and unlock ensure that your set of code, your functions are executed by only one Go routine at a time. Okay, so these are the some kind of basic Go routine primitives, and we can just use them whenever you want. Because this is the very common problem. Let's say about the instead of printer, and in your office, lots of employee can give the printing command. Okay, so at a time, if any requests come, that request must be completed, then another request can be entertained, then another request can be entertained. It is not possible. Let's say I give some print, so some line of data print by the my and some data print by the this printer. So it's not possible. Your data are corrupted. You are getting inconsistent behavior. So some use cases scenario where your codes are at a same time, you ensure that not executed by the multiple Go routines. So those scenario, mutual exclusion or mutex help us ensure that at a time only one Go routine can execute your code and others just wait. Just wait means just try to wait, and once one Go routine completed, just release the lock, another Go routine come take the lock and do the same operations. Okay. So let's try and use this some basic Go routine primitives like your WaitGroup, like your Mutex. These are very commonly used this Go routine primitives, and that help us to write very elegant, very efficient concurrent programming in the Go language. Okay, thank you more for watching this video, and might be this information is helpful for you.